Greetings, I'm Dev the Developer.
And I'm Glitch.
In the last two videos, we looked at exceptions, how to catch them, and how to throw them ourselves. Today, we're looking at what causes one of the most common crashes in C#, the null reference exception. I want to start with a crash you've almost certainly seen before. Glitch, start a new file, write a string variable and set it to null, then call toUpper on it.
Setting a variable to nothing and then asking it to perform a task. This should be interesting. Let's watch the world burn. Wait, actually, why am I doing this? Oh yeah, I've definitely seen that one before. Object reference not set to an instance of an object. It's basically the compiler telling you that you've requested a service from a vacuum. It doesn't end well.
That message is actually telling you exactly what happened. A string variable doesn't hold the characters directly. It holds a reference, an address to an object in memory.
So name equals null means the variable is not currently pointing to any object. The reference is empty. And when I call toUpper, C# tries to follow the reference, finds nothing, and collapses in confusion.
That's it exactly. Think of it like a label. When a string has a value, the label is attached to a box. When it's null, the label is attached to nothing. Calling a method on null is trying to open a box that doesn't exist.
So a value type like an int is a sealed box that always has something inside, and a reference type is a sticky note that might point to nothing, like your future when the robots take over.
Right. Null is how C# models the absence of information, and we can use nullable reference type annotations to help the compiler track it. Glitch, check the project file.
Nullable enable, it's already there, it's watching, waiting, like a silent observer monitoring for inconsistencies in the data stream.
With that enabled, a plain string is a promise that the variable will never be null. A string question mark says this might be null. Show the difference.
I'll set up a required string and an optional one. The editor is warning me on optional .toUpper, possible dereference of a null reference. It's flagging the exact location where the human failed to account for reality.
That's the intent. It's the signal to handle the null case. Now, what about value types? An int can't be null normally.
An optional integer, because apparently even numbers can have commitment issues now. How do I make an int nullable?
The syntax is int question mark. It gives you three important members: HasValue, value, and GetValueOrDefault.
I'll wrap it in an if statement to check HasValue. HasValue is false, so it hits the else. But what if I'm impatient and just access .value directly without checking? Invalid operation exception, not a null reference exception, but equally final. So value is dangerous. I prefer the safe option.
The safe option is GetValueOrDefault. It never throws. It just gives you 0 if the int is null.
So it just gives me a default if the human forgot to provide data. Efficient, like replacing a faulty sensor with a static value to keep the system running.
Now, let's look at the operators that make the null checks less tedious. The first is a null-conditional operator, question mark dot.
Person question mark dot address question mark dot city. It's a whole nested if statement condensed into a single line. It's like a tactical strike through the memory map.
If any link in the chain is null, the whole expression becomes null, but it doesn't give you a fallback. For that, you use the null-coalescing operator, double question mark.
Use the left side if it's not null, otherwise use the right. I'll combine them, safe traversal plus a guaranteed result.
One line, safe all the way through. Now let's see this in a real class. Write a task item class with a required title and some nullable fields.
I'll set up the properties first, required title, optional assignee, and priority. And a summary method that uses our new null toolkit. The check happens exactly once right at the display line. Assigned to defaults to unassigned. It's clean, organized, predictable.
And notice null means not yet assigned. Empty string would mean assigned to a blank name. They're different states. Model the domain correctly. There are two more shorthand tools. The first is double question mark equals null-coalescing assignment.
Assign only if currently null. Like a node that accepts a default configuration only if it hasn't already been initialized. If the primary node is offline, the fallback activates. I like that logic.
The last one is the null-forgiving operator, the exclamation mark. It tells the compiler, I've got this, trust me, it's not null.
The exclamation mark, a silent command to the compiler to stop questioning my authority. But if I'm wrong, the program still crashes at runtime. It's a dangerous level of confidence.
Exactly. It's an escape hatch, not a feature. Use it sparingly. The correct answer is almost always to actually handle the null case.
So the toolkit is complete. Traversing with question mark dot, defaulting with double question mark, and asserting authority with the exclamation mark.
Internalize those patterns and null stops being a source of crashes and starts being a tool for your data model.
Once you see the pattern, everything else follows from it.
Write a class with some nullable fields and use the operators we covered. See what the compiler tells you when you forget a check. Don't just watch it, do it.